So, hi, today I'm going to discuss the next question in the Leetcode top interview 150 study plan, that is jump game. So, what this problem asks us is you are given an integer array nums. You are initially positioned at the beginning of the array, that is the first index of the array. Return true if you can reach the last index. So, basically, this two here is the number of jumps our player can perform from the position ith index. And in beginning, we are beginning from the zeroth index. So it is zero from zero. We can go to one th index or the twoth index. That are two jumps. If it had been one, we could only make it to the first index. Similarly, for the first index, we can jump three times at most, three indexes at most. So basically, we are just have to return the minimum. No, so not minimum. Only this problem only requires whether we can read the end or not. So one way to do this, the brute force solution is we try to simulate all the possible combination. That is, we start from zeroth index. We try the first path, that is we move to the zeroth index, then we move from first index, we try to move to the second index to the third index, then fourth index, and find out if we can reach or not. And but if like for example in the second case, here is zero and our first path uh, does not include actually include this zero. That way, we would need to iterate again and again through this zero to find the actual path. But we don't want that. That would make a time complexity very big because we are trying to cover all the possible paths, and we don't want that. So the optimal solution here is using a greedy approach. So what is the greedy approach here? So, for example, we keep a maximum index that we can move to. So currently when we start from zero, we keep the maximum index we can move to is a second index, that is one. From there we start iterating the array. We go only once through the whole array, that is from zeroth index we move on to the first index, then we compute max for it. If it is greater than the previous max, we simply replace it and nothing else. Similarly to the third, fourth, fifth, and if we if at any index our maximum value is lesser than our current index, we know कि there was no previous path or this one couldn't lead us to the final destination. So we know we can't reach the end. If it does, like the maximum is, if we reach the last node somehow without any interruptions, we know कि uh, our path was there was actually a path. So things would become more clearer when I would code it up. So let's code it up. So let's say int current max is we can only go to the zeroth index. Once it is done, I could start from the iteration from the zeroth array. This is I is equals to zero, I less than nums dot size I plus plus. Now what I can do here is check if my ith index is currently greater than uh, mm, the max, that is the maximum place we can go till, we could simply return a false. If we reach the end, uh, like end of if we don't reach the end or like the default condition, because we are using if condition here, so the default condition I would put is return false. Not at all necessary, but if I don't put it there, the code might break. So yeah, I'm putting it there. The second condition is if I is actually equals to nums dot size minus 1. That is, we are actually able to reach the last index without it the index getting greater than the max. We know ki we have finally reached the last index, so we could simply go ahead and return true. Or else, what we need to do is keep updating the max. So to update the max, what we need to do is current max, that is the current largest index we could reach, and uh, the max between that and the current index, that is I. For example, current index here is 1, and plus 3. Plus 3 because we can reach from here we can reach till the fourth index, the 1 plus 4, that is 5. So what? Sorry, 1 plus 3, that is 4. So we could do nums dot I, and if any point our condition is violated, we could simply return a false. So now let's check if this is working fine. So it is working for the preliminary test cases. Let's check for the all the test cases. So yeah, it is giving 100% complexity. So the time complexity of this code is basically O of n, because we are going over the array only once and doing predefined computations like two if statements and computing a max. For as for the space complexity, we are not using any extra space complexity, just constant. That is, we are using a variable max. Um, yeah, so that's it. Thank you.